Welcome back to the video. In this video, we will be going through the solutions of end semester question paper on numerical analysis and design given by Dr. Shaligram Prajapat sir. So let's begin. The first question over here is find the root of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equation and show their nature, whether they are convergent or divergent in nature. So here's the solution. In the solution, we must make an assumption first. So what we do over here is we substitute the values in the equation x square minus x minus 1 and calculate where it's positive and negative in nature. As we can see, the value of f1 is negative and the value of f2 is positive over here. So the root must lie between 1 and 2. So we take x0 equal to 1.5 as the median value and then continue with the solution. So here is the following equations of gx that can be concluded from the fx x square minus x minus 1. We can calculate x by substituting gx as under root x plus 1 or 1 upon x minus 1 or 1 upon x plus 1 or x square minus 1. Then we calculate the value of gx, g dash x, that is the differentiation of gx. So the differentiation of under root x plus 1 would be 1 by 2 root x, that is 1 upon 2 under root x plus 1. The differentiation of 1 upon x minus 1 would be minus 1 upon x minus 1 whole square. The differentiation of 1 upon x plus 1 would be minus 1 upon x square, and the differentiation of x square minus 1 is 2x. Similarly, now we calculate the value of mod of g dash 1 and mod of g dash 2 and see if it's less than 1, greater than 1 or equal to 1. So when we put x equal to 1 over here, we get value less than 1 and the g dash 2 is also less than 1. Over here, the value of g dash x when g dash 1 is greater than 1 and here it's equal to or greater to 1. And when we substitute x equal to 1 in minus 1 upon x square, it's greater than equal to 1. And when we substitute g dash 2 x equal to 2 in g dash x, we get value as less than 1. And when we substitute x equal to 1 in 2x, we get value greater than 1 and x equal to 2, it's greater than 1 as well. Now for the selection of correct gx, g dash mod of g dash x should be less than 1. If multiple values of g dash x are less than 1, then we choose the least one over here. Now in the table we can see as only the first one, that is that is root x plus 1 gives the value less than 1 in both the cases. So it's the correct one. And the table of convergence we can see over here as here both the points at g dash 1 and mod of g dash 2 are less than 1, so it is convergent in nature. And in the second, third and fourth option we can see both the values are not less than 1, so all these three are divergent in nature. So now we calculate the value using the first one, that is root of x plus 1. Here as we can see, the gx equal to x under root x plus 1 should be taken for the fixed point iteration method. As we have already assumed x0 equal to 1.5, we substitute x0 over here and then calculate the value of x1. The calculate value of x1, that is under root 1.5 plus 1. Similarly, we calculate the values of x2, x3, x4. As we can see, x2 would be under root x1 plus 1 and x3 would be equal to under root x2 plus 2, that is 1.5811 plus 1, that is equal to under root 2.58811, which gives us the value as 1.6065. Similarly, we calculate x4, x5, x6 till we get the values, previous value and the current values same. As now we can see the value of x7 and x8 are nearly same, that is 1.6179 and 1.618. So The error also is between them is very less, that is 0.00101. So hence the root of the equation x square minus x minus 1 is 1.618001. This concludes the first. Here's the second question. In the second question, we need to find the solution of system of equation using iterative method. The equations given are 20a plus b minus 2c equal to 17, 3a plus 2b minus c equal to minus 18, and 2a minus 3b plus 20c equal to 17. So in this, we must find the value of a, b, c using this all three equations. So here a is equal to 17 minus b plus 2c divided by 20, b is equal to 18 minus 3a plus c divided by 20, and c is equal to 17 minus 2a plus 3b divided by 20. Now we assume here as a not equal to 0, b not equal to 0, and c not equal to 0, and calculate the value of a, b, c. In the first one, we substitute b not and c not equal to 0 and calculate a. Similarly, in b, for calculating b, we substitute a 0 equal to 0 and c 0 equal to 0. And similarly, we calculate C by substituting A0 and B0 equal to 0. Now, after substituting them, we get the values as A1 equal to 0.85, B1 equal to 0.9, and C1 equal to 0.85. Now, we take this value and again calculate the value of A2, B2, C2 by substituting them in the above equation. So we get the values of A2 as 0.98, B as minus 0.985, and C2 as 0.63. Uh, then again we calculate over here the values of A3, B3 and C3. The values of A3, B3, C3 can be calculated by substituting in the equations the value of A2, B2 and C2. So we substitute here, as we can see the value of A is 17 minus 0 minus or minus of 0.985 plus 2 into 0.63 divided by 20. Similarly, B and C have also been calculated. So the value of A3, B3 and C3 is minus 0.96225 and B3 is minus 1.0155. C3 equals 0.6042. Now we calculate again the values of A4 using the equation and the values of A3, B3 and C3. And we calculate this till we get repeated approximate values of A3, A, B and C using the previous values, and the current values must be approximately same. The next question is list out 4 disadvantages of Gauss elimination and 3 advantages of iterative method over the elimination method. The iterative method is superior to elimination method due to computational effort is approximately 2n square arithmetic operation per iteration, and if convergence is achieved in less than n iteration, it is significantly superior compared to the elimination method. Another important advantage of the iterative method is small rounding error. The rounding error being the one committed in the last iteration. Thus, for ill-conditioned system, an iterative method is a good choice. In Gauss-Seidel method, we set xi equal to the newly calculated value of the iterated store in the temporary value. The disadvantages of Gauss elimination are as follows. The computational effort is approximately 2n to the power 3 by 3 arithmetic operation in each elimination step. The amount of bookkeeping necessary is considerable. The rounding error may become quite large, particularly for ill-conditioned equation. Any structure in the matrix of coefficient is difficult to preserve during elimination. So these were the disadvantages of Gauss elimination method. Now here's the next question. In the next question, we need to write the algorithm for Lagrange's inverse interpolation. Here we first read the number of input values n. Then in the second step, we read the values of x. And for I equal to 0 to I n minus 1, we read the values of x and y. Then we set the sum as equal to 0. And for I goes from 0 to n minus 1, we set the product as equal to 1. And in the next for loop, we set as j equal to 0 to j n minus 1. And if I and j are equal, we set the product as product into y minus yi divided by yi minus yj. and store it in the sum variable as sum equal to sum plus xi into product, and then we print the sum. So this is the algorithm for Lagrange's inverse interpolation. Now let's move on to the next question. We need to evaluate 0 to 1, 1 upon x square using the 3-point Gauss quadrature formula for the given abscissa, and weights are given as T1 and T2. T1 is 0.77459667 and T2 is equal to 0 and T3 is equal to plus minus 1, and W1 and W2 and W3 values are given over here. So the A value and B values are the lower limit and the upper limit. So A equal to 0 and B equal to 1 over here. Now we calculate x, which is equal to b minus a by 2 into t plus b plus a divided by 2. And then we substitute the values of a and b in the equation. We get x equal to 1 plus t divided by 2. Now we differentiate this equation. So differentiation of x is dx, and the differentiation of 1 plus t by 2 is dt by 2. So we get dx equal to dt by 2. Now we substitute this in this equation, that is 1 upon 1 plus x square dx. So we get the values as ft is equal to minus 1 to 1, 2 upon y plus 1 plus t whole square dt. So the ft comes out to be minus 1 to 1 2 dt upon 4 plus 1 plus t whole square. Then we calculate it by substituting the values. So the minus 1 to 1 2 dt divided by 4 plus 1 plus t whole square comes out to be 0.78527. So this is the solution of the equation minus 0 to 1 1 upon x 1 upon 1 plus x square dx. Here's the next question. In the next question, we need to write the algorithm for Biddle rule for 6 point. So we firstly read the start point and the end point, and we calculate the value of h. The h value is calculated by n minus start divided by 6. And for I equal to 0 to I equal to 6, we read the values of yi, and then we store it in S, where S is equal to 0.3h y0 plus 5 plus y2 plus 6y3 plus y4 plus 5y5 plus y6 and so on. And then we print the value of S. So this is the algorithm for Biddle's rule for 6-point iteration. Now the next question says that write the algorithm for Runge-Gupta 4-order method. In the Runge-Gupta method, we first define the function x comma y and then return the expression. And then we read the starting point, ending point, and the splits. H is equal to ending minus starting point divided by the splits. Then we use a while loop. If the starting point is less than or equal to the ending point, then we calculate the values of k1, k2, k3, and k4. K1 is equal to h into f of x comma y. K2 is equal to h into f x plus h by 2 y plus k by k1 by 2, and k3 is equal to h into f of x plus h by 2 and y plus k by 2. Similarly, k4 is equal to h into f x plus h comma y plus k3, and x equal to x plus h. Starting would be starting in plus h, and then y would be equal to k1 plus 2k2 plus 2k3 plus k4 divided by 6, and then we print the values of x and y. So this was the algorithm for Runge-Kutta 4-order method. Now the last question over here is apply predictor corrector method to solve dy by dx equal to minus xy, y0 is equal to 1 in steps of 0.1 up to y 0.2. So ypn plus 2 is equal to yn plus 2 hf xn 1 comma yn plus 1, and ycn plus 1 is equal to yn plus h by 2 f of xn comma yn plus f of xn plus 1 comma yn plus 1. So by Ewan's method, k1 is equal to f of xi comma yi, k2 is equal to f of xi plus h by 2 and yi plus k1 h by 2. and k is over here is k1 plus k2 divided by 2. So yi plus 1 is equal to yi plus kh. Hence y 0.1 comes out to be 0.9975. Y 0.2 equals y0 plus 2 hf or x of 0.1 and y of 0.1, which we have predicted. So on solving this, y 0.2 comes out to be y0, which we have got as 1, and 2 into h value is 0.1, and the x 0.1 and y 0.1 are minus 0.1 into 0.9975. So the value of y 0.2 comes out to be 0.98005, which is the predicted method. Now we apply the corrector formula to get the proper value of y 0.x, y 0.2, in which we get the values of y0 as 0.9975, which we have calculated in the previous slide. So y 0.2 comes out to be y 0.1 plus h by 2 f of x 0.1 comma 0. Y of 0.1 plus f of x 0.2 plus y of 0.2. So the y 0.2 comes out to be 0.9975 plus 0.1 divided by 2 into the values of x0 f of x 0.1 plus f of x 0.2 over here. So the value of y 0.2 comes out to be 0.982712, which is the corrected values of y 0.2. We can all apply the corrector formula again for more accurate values by putting this corrected value as predicted value in the corrected formula. So this finishes with the end paper solutions. I hope these solutions were helpful and accurate. Thank you.